This is question 18 from exercise 4.2 in Project Maths 2. We have to solve the pair of simultaneous equations, and we are given for our equation 1, 1/3 f plus 1/2 g is equal to 0. And for our equation 2, we're given minus 11 over 6f plus 1/4 g is equal to minus 6. So the easiest way to go about doing this to start with would be to try and clear away the fractions, because they are going to be inconvenient to work with otherwise. So for our equation 1, in order to clear away the fractions, we're going to multiply the entire equation, every term in the equation, by the lowest common multiple of the denominators of the fractions. So the lowest common multiple of 3 and 2, which is 6. So 1/3 f by 6 is going to be 6/3 f, and then 1/2 g by 6 is going to be 6/2 g, and that's going to be equal to 0. And then if we continue to tie that up, 6 over 3 is just 2, so we get 2f, and 6 over 2 is 3, so we get plus 3g, and that's equal to 0. So that's going to be our new equation 2. Our equation 1. For equation 2, in order to clear away the fractions, we're going to do the same thing. We're going to multiply them both by the lowest common multiple of the denominators, which is 6 and 4, so that's going to be multiplied by 12. So that we're going to have minus, and it's going to be 12 times 11 all over 6 f plus 12 over 4 g is equal to 12 by minus 6. Now, for this first term here, I could have multiplied the 12 and the 11 together, but it's actually a little bit easier just to do it this way, because now we can see the simplifying down. So 6 divided by 6 is 1, 12 divided by 6 is 2. So on top we have 2 times 11. So for our first term we get minus 22f. For our second term, 12 over 4 is just 3, so we're going to get 3g. And 12 by 6 is, or by minus 6 is going to be minus 72, like that. And that's our new equation 2. So now if we write these just in line with each other, we're going to have equation 1 is 2f plus 3g is equal to 0. And our equation 2 is going to be minus 22f plus 3g equals minus 72. Now, in order to solve these out, we would prefer to have the same number but different signs in front of either both of our g's or both of our f's. So if we multiply equation 2 and every term in that by minus 1, we'll be able to change this 3g to a minus 3g. So we'll do that. So our equation 1 doesn't change. We're still going to have 2f plus 3g is equal to 0. But for equation 2, we're multiplying that by minus 1. So we get 22f minus 3g equals 72. And we draw a line and we're going to sum this down. So 2f plus 22f is 24f. And 3g minus 3g is 0, so that just cancels out. And 0 plus 72 is 72. So we have 24f equals 72, which means f is equal to 72 over 24. So f is equal to 3. And now in order to get a value for g, we're going to take our value for f, and we're going to put it back into one of our equations. And it doesn't matter which one, we'll get the same answer either way. So we'll take equation 1 this time. So instead of 2f plus 3g equals 0, it's going to be 2 times 3 plus 3g is equal to 0, which means 6 plus 3g equals 0. So 3g is equal to minus 6, which means g is equal to minus 6 divided by 3, so g is equal to minus 2. And that is the solution for that simultaneous equations. And that is that.